Now, what is object-oriented programming? So these are the object-oriented principles. So you see, we have basic object-oriented principles like abstraction, encapsulation, inheritance, polymorphism. Then we have class and object. We'll look at each one of them. So what is an object? So if you ask me what is an object, object is basically anything which can independently or uniquely identify itself. In fact, we ourselves is an object. We can uniquely identify ourselves maybe using Aadhaar ID, that is for India. In US, maybe social security number. We ourselves use a unique identity, right? And we ourselves have certain attributes. Attributes, the way we look at, the way we actually move our hand or legs, these are all our attributes. The way we eat, the way we behave, those are all attributes. Whereas the kind of operations we can do, like for example, we can walk, we can run, we can jump, we can work, we can program, all these are operations. Like you look at it, object is nothing but anything that can be uniquely identified. If you take an e-commerce word, a product catalog, like I was mentioning earlier, a product ID, product name, product description, these are all the attributes or the data part of it. Whereas the operations possible on it, like get product ID, get product name, get product description, those are all the operations that can be possible on it. So these all together becomes an object, but actually objects simply represents a unique entity. So object is nothing but not just the attributes part, which is the data. It also has some operations bind to it, where that is how you actually ensure whoever is want to talk with your data, whoever want to access your data, you are allowing them through your functions provided in the object. And it's the responsibility of objects to ensure the right access is given to the right clients. It's not like you have the data and you will publicly open it. No. Now, what is a class? Class basically is nothing but a template or structure. When I say structure, let's say, for example, we want to enroll our kids to a school. Now, what is the first thing you see in your mind? They will give you an admission form, and the admission form, only when you fill your child details, that's where it becomes unique to you. Otherwise, up to that point, it is just a structure, and that's the same admission form given to everybody. That admission form in our programming world, particularly object oriented, is called class. It's a structure where it needs certain details. Only when you fill and put some data into it, that's where it becomes object. So class is nothing but simply a structure that consists of certain attributes. Now, in the programming world, what and all and where and all places we can create these classes and what types of it. We can create class interface, we can create class with blocks, we can have class with constructors, we can have nested classes, we can have class with methods, fields, or variables. So overall, if you see, you can create interfaces, you can create class blocks, constructors and class, nested classes, classes with methods, and classes with fields or variables also. Now, what does it mean by abstraction? So abstraction simply means you will give only the details it is required, and you will not worry about what are the details it is not necessary to you. Like for example, let's say if I want to drive a bike, what is the minimum thing I need? In order to drive a bike, all I need to know is how to kick it, then how to accelerate it, and how to handle the steering. Do I need to know how the engine functions internally? Do I need to know how the circuitry works? That is all hardware I don't care about, right? So this is called abstraction. Abstraction means you refer to the essential characteristics of what is required rather than worrying about how it internally works. So internal details which are not necessary, it will be hidden. And believe me, every human relies on abstraction on everything. There is nothing one thing you can say I know end to end. Everything, starting from the way you wear the t-shirt, everything we rely on abstraction. Now, what is encapsulation? It is more about binding together this data and functions related to that data together is called encapsulation. And why it is important? It is important so that when some other class want to talk to you, you have a way in object oriented to prevent it by saying, no, I will not let this data accessible to you, or I will control the data so that only the class functions can access, only the functions within it can access, not anybody outside. So it is like tightly packing together or coupling together both the data and functions so that I can give access only to the particular customers I know, only to the particular classes I know. Beyond that, if anybody is there, I don't want to give access to them. All that you can control. Now, like that we talked about, like encapsulation is more about binding together methods and functions. So members are nothing but data here. So when you say members, I would say members means both methods and functions, methods or functions and data also. So here, if you see in this, when you say data members, it is purely about data. Here it is about functions. Now, whenever somebody want to access this data, you have a control through methods where anybody who want to access, they have to talk through these methods. That means you are putting one more guardrail or interface to access your data rather than availing them access to the data directly. That way, more security is ensured. At the same time, you are ensuring that nobody can access your data publicly. Even you can write a code in such a way so that only some of the confidential data can be accessed only by some of the private methods you have written it, not by any public methods it is accessible, when that is also possible. This and all is only available and possible because of the way encapsulation is done. Now coming to inheritance. Inheritance is more about how you acquire features of a superclass to a subclass. Here in this case, if you see, I can take a sandwich with a coffee or a hot coffee or frozen coffee, any one of them. So all this, it's like sandwich is inheriting from coffee, hot coffee, frozen. So it is more about inheriting it. Like simply, besides this example, if you look at, we inherit some of the features from our parents, like our mother or father, and sometimes from our uncles. So that is actually an inheritance. You acquire property from somebody upper or your ancestors. So here in this case, it is sandwich where it is inheriting some of the features. Similarly, if you see ice cream is inheriting from a frozen base class. So something like that. And inheritance helps you. The main advantage of inheritance is reusability. That means if you write one time and you can use the code multiple times. That's what the slogan Java also make. And other than that, let's say any other guy who want the same functionality, rather than rewriting, they can simply extend your class and use it. That's another advantage you have. It's more about the reusability. And automatically all the things like overriding, dynamic binding, overloading, all the things automatically comes with inheritance. Now, what exactly is polymorphism? Polymorphism is nothing but one interface and many forms. Like for example, when I say one interface, like let's say if you consider me, I am a trainer in some X company. I am an employee in other company. I am a father of two daughters. I am a son of a mother. So if you see, I'm playing four roles here. And in each instance, I am the same person. So I am a polymorphic object here, isn't it? Because I'm not changing. I still remain the same, but I have different roles to play together. That is called polymorphism. Polymorphism means one interface, multiple forms. Based on the situation, if a particular function is behaving differently or a particular operator is behaving differently, that's called polymorphism. And Java supports two types of polymorphism. One is compile time, another is runtime. So for compile time polymorphism, one example, or before giving an example, what exactly is compile time polymorphism is any binding or any polymorphic thing happens during compilation time is called compile time polymorphism. Whereas during the execution of the code or while code is running, if there is any polymorphic binding happening, that is called runtime. That means during execution time. So for compile time polymorphism, when you actually overload your code, that means you write some set of overloaded methods, those and all happens during your compile time. Whereas when you actually execute the code during the execution time, if there is something like overriding, so where actually you can customize your code than what you have in the super class, that really happens at runtime or execution time. That comes under runtime polymorphism.